The structural two-piece oil sump on this engine is quite a nice design. First of all, it's very strong. It's a big aluminum casting, and it actually incorporates the engine mounts in the front. It also serves to very much strengthen the lower part of the block, which is, open. So this was, without a doubt, race car design, and in fact may have even been cutting-edge technology for the day. And it really demonstrates, how expensive these engines were probably to both design and construct. Here's a look at the oil pickup. On the bottom side of the engine, there's another alloy pan that bolts on here. And as you can see, there's this tray which separates the oil level, which is about here, from the crankshaft, and that's called a windage tray. And what that does is it keeps all the oil down below the spinning crankshaft, because under race circumstances, braking, cornering G-forces, the oil can slosh up into the crankshaft, and the crankshaft beats it up, foams it up, and causes power losses too from the, all the friction. So that's the windage tray. And then also inside of this is the pan, which bolts on there. Inside of the pan, there's another baffling where that pickup sits in this round area. So the only big way in or out is, through this hole. There's a little drain hole here and at the back. So what happens is under cornering, the oil stays right in the center of this pickup. One downside I can see, one big downside, is that there's this gasket, which connects these two pieces, which seals it up, and that actually sits underneath the oil line, even statically. So I foresee that this could have a lot of potential for leaking. Normally, your standard oil pans, which I'll give you a look at, just a normal run-of-the-mill oil pan for the day. This is from the contemporary Fiat 1200 engine. It's just a stamped steel pan, and there's just one baffle to prevent front and rear sloshing. So the oil level is down in the pan, so there's no leaking there, and even these can leak from the gasket. So there's a good potential for leaking on this OSCA engine. Okay, I'm just putting the cylinder head on here, and I'd like to point out a feature that I find a little bit unusual about this engine is that it has an intermediate shaft to run the camshafts. So right here, that's the intermediate shaft. And down here is the gear that drives it on the crankshaft. So it runs this chain attached to a gear, and then there's another gear which runs these two chains which actually run the camshafts. So in other words, this chain here on top is not this chain. There's a shaft in between which changes the speed of the chain, reducing it. So I find that a little bit unusual, although I have rebuilt some other overhead camshaft engines. I haven't rebuilt a lot of them. The Porsche 911 engine does have an intermediate shaft, but it's gear driven, so there's not two chains. And while we're up here, another thing that I find a little unusual on this engine is this is the drive for the fuel pump, which sits high right up here. And it's driven off the intermediate shaft. There's an eccentric lobe in here, which runs a little shaft that pumps the fuel pump. I'm not sure it's a great idea to have a fuel pump high, because now it has to suck up higher the fuel from the tank, whereas normally you see them down low on the side of the block. But it is nice that it's easy to get at. The one unfortunate thing is that it doesn't have a fuel handle pump. I really love fuel pumps that have another handle to prime the carburetors. When you don't have that handle, you have to crank the engine to prime the carburetors. So if you haven't run the car in a while, you're stuck cranking the engine to get the carburetors primed. And I have a suspicion that with the extra draw in height, that this engine will be hard to prime. So that's a little bit unfortunate. The oil flow at the front of the engine is somewhat unusual in that pressure is supplied to the front main bearing, but from there it actually travels up these slots along the side of the crank snout. You can see them here. So the oil comes up these slots, and then it goes into a centrifugal oil spinner, which spins out the heavy particles from the oil. And then it goes around and back into the center of the hollow crankshaft. And it actually goes through this nut. The main crank nut has a hole in it. So it took me a little while to figure out what was going on here. But yeah, this hole, the oil comes back through this hole, and then it feeds the first main bearing. And then the oil pressure proceeds in a normal fashion, back down through the crankshaft. And you can see here at the front of the engine, this here is the chain that drives the oil pump and the ignition timing, the distributor. This is the distributor drive. So it's an interesting feature, but if your oil pressure fails because this chain breaks or something else goes on, likely your engine stops running because the spark stops. So it's sort of a good feature. I'm not too wild about this single chain driving all of this stuff out here. And in fact, this is the reason this engine stopped running, was the clip came off years ago before I ever had it, and when I took this apart, this chain was just at the bottom of the oil pan here. So it's a weird sort of thing. One of the many weird things about this engine, sort of interesting. And here is that centrifugal oil filter or spinner that I was talking about, which sits at the front of the crankshaft. And you can see there's these chambers here. Let me get some light on it. There are these chambers which fill up with this grit, and what's in here is it's just full. I haven't cleaned this out yet. It's full of caked in on about 3/4 of an inch thick sediment, which, by the way, has the foulest smell I've ever smelled in any engine. It's this weird sulfury, just hard to describe how bad this stuff smells. But these chambers, like little honeycomb chambers, are almost completely full of this sediment. So the oil was going around, getting spun out. The sediment was getting spun out. So I have to say that it was working very well, in the sense that it accumulated a lot of sediment over the years, even without an oil filter. Now, I think that this probably should have come off a number of times and been cleaned by whoever was running the engine, and I will definitely keep an eye on that. Here's a look after several hours of cleaning this filter and literally chiseling out the sediment that was in here. It was quite a job, and I have to say this stuff in here was the foulest smelling stuff I've ever encountered inside of an engine. In fact, it was like the second worst thing I've ever smelled, most toxic thing, and I don't really understand why. But anyway, here's the filter after it's been cleaned out, and you can see how deep these cavities are going down into the filter itself right there. And the oil flow inside here is interesting. It's quite constrained. So there's this cup that goes in the front of the crankshaft, forcing the oil around the outside and then down the center. And then additionally, there's a cap with more constraint. So this slip fits inside here, which forces it to go make a U shaped flow around that right there. So it's a very constrained flow. It's not like a just willy-nilly going around. And what this cup does is it keeps this sediment separate from the oil, the supposedly clean oil in the center. Now, one interesting thing is that these were basically full, and they had accumulated a lot of sediment in here. And this engine had been apart once. It had been rebuilt once. Presumably, someone cleaned these out when it was rebuilt. So within the life, or less than one life of the engine, these are filling up. So I imagine these need to be cleaned out on a more periodic basis. I have to reiterate, it was very difficult to clean these out properly, and I don't like this design at all. So I'm sort of stuck with it, but that's what it is. And here, with everything installed, you can see the somewhat circuitous route that the oil takes. So it's pumped forward and then out right around this area of this cupped washer. So it gets spun out into the chambers out here, and then it goes down through the center hole back into the crankshaft through the hollow nut. Going back several videos, when I took this engine apart, I noticed that the bolt, which sets the cam timing on this engine, was not a factory bolt. So I decided to degree in this cams, both the cams. And the other thing that I noticed when I took it apart is there's a very fine line right scribed on the camshaft. You probably can't see it, but it's supposed to line up with this mark. And it was off on the exhaust cam ever so slightly. Almost like it's sort of lined up, but not like exactly. So I decided to degree in this cam. Okay, so this is the degree wheel on the back of the flywheel. And there's a lot of lines on here. I'm not going to describe what they all are, but my suspicion was confirmed. The exhaust cam was out by more than I suspected. What these lines all are is when the exhaust valve opens, closes, when the intake valve opens, closes. So there should only be 4 lines on here. I got a bunch of them because I was playing around with the setting. So what was happening is the exhaust valve was opening at 38 degrees before bottom dead center. It was supposed to open at between 63 and 68 degrees before bottom dead center, so it was way off. And then it was closing way too late. So it was supposed to close at 18 to 25, but it was closing at 30 degrees. So there was a lot of what they call overlap. That's when the intake and the exhaust valves are open at the same time. So more like a race engine. And I don't think that was on purpose, but I could be wrong. Maybe someone set it up like that. But anyway, the engine did run, and it was running like this, but I reset it to the factory settings, which turned out to be only 6.8 degrees off at the cam, which is why it didn't look like much, but it was translated to a lot more degree motion on the crank. So now I've set it to the factory settings, and all is good. All the lines line up, and all of these degrees when they close and open correspond to the manual, more or less. It depends on the exact valve lash. And what I'm planning to do is let the engine run in so that the valves seat properly because they've been cut. And then I'm going to recheck the valve lash, and I think I'm going to have to make some more adjustments on the valve lash. So the starter motor is sort of interesting. It's a very high quality unit, and I have taken apart a lot of starter motors, Lucas, Bosch, a lot of the modern ones, and I find this to be probably the highest quality that I've ever taken apart. And it is built by F. Scaglia. You can't see the letters there, but that says Scaglia Torino. It's something I've never encountered before. And another interesting thing about it is that the drive pinion has a clutch on it, a one-way clutch. So this wheel, this drive wheel, which drives the flywheel, the armature turns and it will turn the flywheel, but if the engine kicks back, there's a one-way clutch, so it spins backwards. So probably to prevent damage to the starter motor. And right here is printed FIAT OSA, made in Italy. Not OSCA, but OSA. I'm not sure what that's about. And here on the solenoid is also printed FIAT in the type number.